Video for chapter 3 is just going to be on some vector basics. So this is actually some review, a lot of this is review of the stuff we talked about in chapter 2 already. So vectors. So remember, vectors are these things, they have both a magnitude and a direction. So there's lots of examples of these. So displacement, velocity, and acceleration, which we introduced in chapter 2, and also force, which we'll get to in another couple chapters. But these are all things where the direction matters, right? So a velocity, so if you're traveling at 2 meters per second, well, 2 meters per second east is different than 2 meters per second west. Or force, which is a push or a pull, I mean, pushing in one direction is different than pushing in a different direction. So those directions matter. So that's what the vectors really are. Now, there's also lots of examples of things that don't have a direction. So these are called scalars. So scalars only have a magnitude. So remember, displacement had a direction, but distance did not. So time doesn't have a direction. Mass, it doesn't make much sense to talk about a direction with mass. Speed, remember, is defined as a scalar. So velocity is the vector. And of course, temperature, it doesn't make a whole lot of sense to talk about temperature with a direction. So those are the scalars. So, and of course now chapter 2 was all about the one-dimensional motion. So now we're going to move into two-dimensional and three-dimensional motion. So we need a way to specify all of these directions. So we're going to do that with vectors. So, and again, just a review of the notation. So the usual way we indicate a vector is either in boldface or an arrow over the symbol, right? So for velocity, we use a V. So it's either a V in bold or a V with an arrow. So your textbook likes the arrows. Some other textbooks like to do the bold. Personally, I like the arrows since it's easier if you're handwriting or writing things on the board. The arrows are easier to do. Okay, so and often, so your book talks about this graphical representation of vectors. So you often use an arrow to represent a vector. So the length of your arrow is proportional to the magnitude, and of course the arrow has a direction, so it points in the direction of your vector. So here we've got some velocity vector, right? So it's pointing off in some direction, so that's the direction we're moving. So the magnitude is 3.6 meters per second, and the 3.6 meters per second is going to be proportional to the length of this arrow. So, and remember, so you need some sort of a scale if you're going to do this, right? Because a particular distance, right? Because we draw these things on a piece of paper or a board or something. And you need to know, well, how long of an arrow are you going to draw for 1 meter per second? So maybe it's 1 centimeter per meter for each meter per second. So I draw this arrow 3.6 centimeters long. But you need some sort of a scale so this proportionality will work. All right, and then finally, we also talked about the magnitude of the vector already. So remember, the magnitude of the vector is just the number part or its length, right? So you're basically throwing out the direction information. And the notation is that you use so A with the arrow over it, so that's our vector, and the absolute value bars indicate that we just want the magnitude. Or sometimes you also see this written as A without the arrow. So A without the arrow just means the magnitude of A.